Bale. Papa Bale. Welcome to the channel. Yeah. That's a wonderful start to a beautiful day here in Michigan. Yeah. Well, actually, it's almost over, but who's counting, right? Okay, so I've got the. This is the 180 90-degree relay. You got 180 magnets in the rotor and you got 90-degree coils. But for each 90-degree coil, there's a buffer coil. It's not hooked, it's not designed, it's not there to generate anything really. It's there, it's an extension of the drive. So it's really just there to get added torque. And whatever other benefit you can get from it. There's no real, there's a reduction in amp draw. So, I mean, it's really a win all the way around with that. Yeah, let's turn it on and I'll explain where I'm at in the building of the circuit. We're not using the SSGs currently. I'm working on building something else. Now see, I don't like that those amps are on there right now, but so we're just making sure everything's running relatively smoothly. Now I haven't put any resistance on the circuit yet. So that's going to be about how fast it's going to be going. So I got the load. Oh, there's no load right now on the circuit. We're drawing about 200 milliamps. So it's pretty solid. It's not like it's power hungry or anything currently. So do you see how these two coils here can work with the 180 90-degree relay? Because it still works because these two coils are together and these two coils are together. So when these two are on, these two are off. And when, vice versa. So that's awesome. All right. Currently, right now, the amp draw is virtually equal. I have all the wire is being used right now, so I got 1,660 turns of 20 gauge. Well, the second trigger strand isn't being used, but all the drive strand is being used. Over here, the 20 and the 22 are in series with this 16 gauge coil. The amp draw is significantly low because there's more wire in the circuit. There's more resistance here than without the coils. But since it's hooked up to the drive, you get a pulse too. You get that electromagnetism involved with it as well. So it's like I can't see the drawback currently. But maybe the one will present itself. It's air core. I'm working with air cores. And yeah, so just for right now, that's what I'm doing. This is designed for air cores, so that's what we're using for core right now. It's air.
Core sub.
Nice, thank you. So let's make a drive. That's not what I mean. Let's make a generator side to this thing.
Pingu asks, what are we, or what are you making?
It's a relay. It's a pulse motor relay.
The A Hill is in the house.
Hey Hill,
For Cleveland.
what's up? All right.
You said awesome. Keep up the good work.
Okay. I'm debating how I'm gonna hook this up because I want to do BEMF and I want to do the flow through from the collector. I want to do both, and I think I just need 2 diodes, but I'm not really sure. I know I clipped this to the collector, and then I put a diode so that we get no backlash to the transistor. And then do I put a reverse diode on the same line? Or do I create another line? That's where I get confused. And then recombine them. I'm gonna try putting them in the same clip. I can see that's not gonna work, maybe. Man. Oh, okay. Not gonna work. Because what I want to do is I want to have. See, now if I could just solder this right to this clip, that would be good. But I don't think I can do that. Maybe I can do that. Well, we got it. We got it.
We got it.
Oh, but I flipped it, so we gotta flip it.
We got it still. Yeah.
Still got this.
Still got it.
Man, you gotta be crusting me right now.
Yeah, Josh.
Why did that want to work that one little time? Alright. We can't use the little diodes. They're not going to clip. Here we go. Oh man, that is so disappointing. I thought I had my screwdriver in my pocket.
Right here.
Yeah. I thought I had it. That would have been so cool. It was just right in my pocket, but no. So we're going to use these bigger diodes that kind of do the same thing. They're 1000 volt, 3 amp diodes. Yeah, this might not work either. I didn't even think it through. Man. You know, I don't think the clip thing is going to work with the back EMF. Not without solder. I don't think it's going to work. I'm trying to think of what I could use. And I need 2 clips. Here, let's try this. We'll go here. Yeah, we're just going to clip them in order, I guess, in succession. We'll worry about resistance in a little bit. Alright, so we got the normal diode. I don't know if this is going to work, but it should work. Man, I can't see crap, man. Yeah, that isn't gonna work. I need to get the weight off of that thing so it doesn't slide around. So there. There. And then where are we gonna clip it to? Straight to the battery? That's another thing that I wanted to ask. Clip it straight to the battery, or do we want to go into the cap bank with it? I don't know. So I guess we'll try and go straight to the battery. I need a god dang clip.
A clip. We need a clip. Doctor, we need a clip.
Alright, now there's a lot more clips involved with this build, so.
We got all kinds of clip. We got clip. We got other clip.
Clip and other clip.
We got yet another set of similar looking clip, a different clip.
So we went right to the battery with that, and I guess we're just gonna ground this now to.
We're gonna ground it on up. Yeah, grounded. Spanish.
Alright, I can't think, so.
Sorry.
Yeah, no, it's not your fault. Alright, I think this is what we want to do.
Welcome to the channel.
Hello everybody, welcome to the channel. I just don't want to blow this up, and my son's making a lot of noise. I don't know what's going on. He's having a good time though. Alright, they just can't be touching each other. That's what it can't do.
No touch. Ten likes.
Alright, so we got the diode, the back EMF diode. That's all hooked up. Let's hook up this one. No. 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 What's up? Yeah, you come in.
He said no 3 times. That was funny.
Oh man.
How's it going, buddy?
Alright, let's test this and see if this works. We're gonna see if the battery charges.
Charging the battery with 10 likes on it.
Oh man, I'm just thinking if there's anything that I might have forgotten.
I want to hook up the PS4 to my TV.
Wait, just
Yeah.
now.
It's a whole
Go ahead, dude.
thing.
Hook it up.
Paige has one in mine.
I think there's like 2 of them out there. There's one for you.
I think there's one in the drawer still.
Yeah.
I'll try to find the controller for that one.
Okay.
I hope so.
See, that's why I said no before I even opened the door. It's like he wants me to
Move the house.
go right now and do that. And I'm like, no. 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 All right. So if we want to hook up the relay, this connection has to go across to the other battery. This one. So much red on this, it's hard to tell what's what. So just give me a second here. All right, yeah, that, when they start like gripping everything, man, it's time to take a break at that point, and
Yeah. Gripping. And then we're 20 minutes in and we're taking a break. Yeah.
No.
It happens. It happens to the best of us.
I know, but we're good. We're good. We're not gonna take a break right now, but yeah, we could so like have an issue and need to take a break, but all right. Then we gotta hook up the other one to this battery over here. So I was thinking, since I figured out about the Utron, I've been trying to get one to spin, right? So I got a brilliant idea. So I just make my rotor the shape of a neutron, with a hollow center, with the geometry in the middle, and say copper infused PLA to start. And we're going to put the neodymium sphere in the center, and then we might make room for cubes like this. Maybe a 6-inch one, and then you have the cubes here and the neo in the center. But or you don't have the cubes at all, and you just have the neo in the center. Or you only have the cubes and you don't have the neo in the center, and the center remains hollow.
Hollow center.
Yeah. It's a lot of options. Alright, so let's start fresh here. Alright. I'm not seeing more of the diodes. I might have to look in one of my bags. Well, I mean, if we're just gonna hook them up the way they're hooked up right now, I can use the little ones. And I think it needs to be hooked up the other way. I don't know. Maybe we just worry about the BEMF part of it later. Oh, this is a big one. I'm gonna need all of this. But let me get it out of here. That was unfortunate. Okay, nothing broke, but I mean, it got all tangled up. I don't like that.
Lucky.
All right. Alright, and then we need to take no, this is a long one. This is a short one. Here we go. Alright, so that's grounded. We need to take these and put them over there to that battery. And just leave these clipped together, I guess. Alright. So, the red one. Power in. Alright, I'm not going to plug that in just yet. I need to make sure this side's good because it's like getting taut.
I don't know, do you hear something? Yes?
Yo.
Alright.
I can't find like the TV plug. So, you know, like the PlayStation.
Please, I'm not finding you an HDMI cord right now.
It's fine.
Okay, you want to look for one?
Yeah. I guess I will look for one.
Alright.
Agenda item.
I'll be right back.
It would appear to me that we're going to need those cap banks. And it's totally what we did with all those diodes. What's screwing everything up right now, pretty sure. And then what I did, not what we did. Right. So that's the other drive. Okay. Cool. All right. We're getting there. We are getting there. Um, I think 2 more connections. We got lights on. Lights on. Alright, let me make sure that other one is good to go. And then we'll have them both on at the same time. I need to get a multimeter on this battery though. No resistance yet. Just making sure everything's gonna work. So far it's working. Seems like it's drawing way too much. And it seems like this coil has got some magnetic issues right now. Might be the transistor. I'm trying to think whether it's this one or that one though. This one is this coil, so. So it's going down really fast, in my opinion. All right, so let's start putting some resistance on it. I don't know about a pot though. I don't think I'm gonna do a pot. Not with this right now. Alright. Think here. Go right here. Come on now. I'm gonna put 460. The other 460 is broken, so yeah, the end broke right off of it. Like nobody's business. Alright. We're gonna do 680.
just need.
Alright. I need the other one. There's a lot of flow in this system once it gets going though. So that's 680 ohms. It is a little slow on the wheel, but that's okay. Oh, no, we're going down just as fast it looks like. But we'll see.
This looks cool. What are you making?
Well, it's a 180 by 90 relay. So the magnets on the rotor are 180, and then the coils are at 90 degrees. These other coils here that are 180 of the 90-degree coils are just extra wire on the circuit. It's the drive circuit. So I attached it to the drive. The trigger is not extended. So we're gonna put some ohms on the drive.
Interesting. Must take a lot of effort.
A little bit of focus and concentration. It actually helps me a lot, you know. It's but yeah, you're kind of on the right track. All right, so we're just gonna need find the drag line. This one. I wish it was that one. We're gonna put 220 ohms on the drive line. Oh, we're probably gonna need less than that, but we're gonna, I guess, start there. I think if we should put, where's my other, jacket here? Here it is. Here they go. Let's do 2.2 ohms on the drive line. Right. Take this one back. I'm running out of 680s, so I gotta conserve. Hopefully all these clips are working, because when they smoke up, you need to change out that clip and throw it away, because you put it back into circulation. I never tested to see how much was coming out of that, but it's not where I want it to be. So we have, I think, I forgot how many ohms we have on the trigger. I think 680. And then we got 2.2 ohms on the drive line. Wow. This is definitely an experiment, that's for sure. So now I'm thinking we should hook a pot up. Where are we gonna put it though? Let's see if this will work. I'm gonna take the baseline, leave the resistor in there. Maybe we put a smaller resistor on there. No, those are 470s, that's right. That'll work. Okay, I guess we can put this one, this is only gonna swap which way you turn it. So, whichever way that is will work. Alright, we got a clip down here, that's great.
Brian says nice lad.
Thank you, Brian. Alright, so we got this on there, and then this will go to this one. I think I'm gonna have to extend the length of these extenders. Hopefully I hooked that up right. I don't know, something tells me that I didn't hook it up right. For sure, something's not right. Alright. Let me do this. Yeah, this isn't good. I think I'm just gonna hook up the SSGs again for
Ah,
right now.
worth a shot.
Yeah, I don't know what it is. I have no idea.
But you got it on camera.
Yeah, that's good.
Mm-hmm.
Yeah, it sucks. The minute I go from power supply to batteries, it's just phooey, man. It's BS. No, it's just different. That's what it is. And I think it was running better on batteries than it was on the power supply just now.
Power supply. Supposed to be better than that.
I mean, it runs. Good for that, but I mean, it's not a very good relay the way it is. I mean, with the power and everything. Battery goes down too fast. I remember having a lot better runs than this with this system than I'm having right now, man. It's like, I don't even know what's going on, really. I know I'm missing something. I don't think this pot is functioning, so. And then I was thinking how easy it is to hook a pot up to the SSG circuit and all that. So I might do that real quick. I'm gonna take a little hiatus. I'm gonna go stretch my legs for a minute. I'll be back in a second. I might talk about this for a second while I sit down. I'm gonna talk a little bit more about my rotor. You know what? I have no desire to get back into this clip, all these clips right now and redo all this right now. I got no desire to do that. So, I'm just gonna try to explain what my new rotor is gonna look like. And then I might be doing a collab rotor. That might be awesome. if we could, get together and see about that beat. Well, that would be cool. I like your design for sure. But I'm gonna be doing an Utron rotor. So it's gonna be 2 cones. I have an Utron. I'll show you. Some of you might already know what that looks like. All right, so that is a baby Utron. It's about 1 inch. And I'm just going to make the rotor the shape of a neutron. And I'm going to try and either make it a bobbin so I can wrap copper around it, or make it out of copper, or copper infused PLA and then wrap it in copper. You know, but keeping it safe, because now that I'm going to make it a rotor, it's going to spin. Just put it on a shaft like that, slide it down. But the one that I'm working on right now is designed for vertical format. Like this one right here. Now that shaft is bent, so this is just a prototype. But it has a Utron in the middle, and it's an 8 magnet rotor, and all the magnets are attached to that Utron in the middle. Lots of friction with this too, so it's just a prototype. I'm gonna make some changes. Shoot.
The sound.
Yeah, and the shaft is bent, so
The shaft is bent.
yeah. See, with this one, like, if I make it like 6 inches in diameter, like that, and then I put the neosphere in the middle, or maybe make it 4 inches and put the neo in the middle.
Dang.
This is an N52 neosphere. It's got some, I guess, ferro fluid on it. I need to wipe it down, actually. And it's going to go in the center of this thing. And then I may or may not have some outer magnets. There, see, nice and shiny. Yeah, I like this. It's got flywheel capability. It's got 8 neo cubes on the outside, and it's a 100% print, but it's got very light amount of weight on the inside, except for that Utron. That's solid plastic. So that's on the shaft. You get this going, man, and it'll, I don't even know. It'll spin a fan pretty good. That's what I'm saying. Heck yeah, I love that thing. Yeah, the magnets are just taped in there. It's prototype. It's just a a hamster wheel with 8 hamsters in it, and it runs around a Utron in the middle. And that magnet, that electromag down there is 12, no, it's 16 gauge, so it's really, 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 really strong. I mean, you're drawing an amp at like 5 volts, but you're also going, 1200 RPMs at 5 volts. So, it's cool. I'm loving it. Yeah, so what I'm gonna do is I'm gonna look for some conductive paste or like conductive adhesive, and I'm going to make 2 halves. I'm gonna make 2 cones with a little divot in the middle, and I'm gonna put that sphere in the center, and I might put other holes in there to put other magnets in there to make it easier for it to spin in case the ball wants to like move around and stuff, because it's bipolar. Even though it's a sphere, it's bipolar, so it's hemispheric. The magnet is always hemispheric, so you want to be aligned properly with your electromags or whatever you're going to use to spin. But it's going to be electromag, so you don't have to worry about it. Yeah, man, that's going to be great. I might even be able to maglev that thing the same way I'm doing it right now with the toroids. That would be awesome to have that thing magleved, because then it would be spinning like, yeah. And I'm talking about, see that shape in the center? Having the whole rotor just be one of those. And have all the magnets you need like inside of it. So it might be this, it might be that. But I think now that I've hooked up all the pots and the resistance, and I've possibly hooked them up wrong, yeah, I was just gonna like mess around with this for a second, but I don't think I'm gonna do that. Yeah, I keep on telling myself, man, you're gonna mess with that. And I'm like, no, I don't think I'm gonna mess with that. Not right now. What I would do though is I would add the second trigger in series with the first trigger on this one. That's the one. That's what I would change. So the trigger strand is longer, just as long as the drive is. So right now the drive is twice as long as the trigger. And I think that's actually causing an issue. And that's my rotor right there, man. That's a tight rotor. But you want to know who's got an even tighter rotor? You want to know who's got a better rotor? Beat Reachy reaches. I always struggle with that. Beat reaches. He's got an awesome rotor design that is a 9-magnet rotor design, and it's going to be awesome. It's just gotta make that.
Yeah, it's gonna be, I wanna see.
Alright, so yeah, I'm like out of it. I think I can do that trigger thing though right now without any problems. Just need to find a clip. Or, you know what I mean, one of these, but a single one. Yeah, I don't know. If I can't find it, then I got a nice idea. It's kind of a weird idea. I don't know if it'll work. Um, nah, man, it's too much. It's too much right now. But I was gonna hook up my little switch here on that rotor down there with the coil that it's on underneath there. Oh man. But it'll have to be another time. It's just, well, I mean, I can't find the dang clip. Around that. Yeah. All right, so I think I'm going to take a hiatus. I'll be back. I'll hook up the SSG, just one of them this time, and then we're going to run this rotor down here with my reed switch. Let's see how that is going to work out. Oh, not good. Oh, there it goes. All right, I think that'll work. Or instead of using the homemade one, oh, we use a high frequency one. I think that'll work. And then we decide whether or not we're going to hook this up to a transistor or not. But I think we're going to give it a break for right now. I'll get back to you. Peace out. Have a wonderful night. Please subscribe. Bye now.